Does Pluto hide a spectacular secret? Just because the celestial body has lost its official planet status does not mean that it has disappeared from the center of astronomical interest. Quite the opposite. After all, NASA's New Horizons probe has taken a close look at the bitterly cold dwarf world and, in doing so, has brought something incredible to light. Since then, evidence has been mounting that life could actually exist on Pluto. The world of mnemonics is also apparently subject to the principle that nothing is made to last forever. After all, the sentence "My father explains our 9 planets to me every Sunday" has long since become obsolete as a mnemonic for the order of the planets. As is well known, the number of members of our planetary system was reduced from 9 to 8 on August 24, 2006, because Pluto was removed from that very list on that day. But what actually led to the reclassification of the small celestial body? Well, it's quite simple. Experts had detected more and more Pluto-like objects in the remote Kuiper belt, and to prevent the list of our planets from bursting at the seams in the future, the International Astronomical Union decided to redefine the term planet. For a celestial body to be considered as such, it must orbit the Sun, have an approximately spherical shape, and have cleared its orbit of other objects through its gravitational field. Ultimately, it was the last criterion that sealed Pluto's planetary fate, which is why it has since been listed in the newly established class of dwarf planets. There is no question that Pluto has truly earned the addition dwarf. With a diameter of just 2,376 kilometers, it's in fact more than 1,000 kilometers smaller than Earth's moon. In terms of cold, however, the dwarf planet has no need to hide from the other members of the solar system. On its surface, the average temperature is a frosty minus 233 degrees Celsius, only 40 degrees above absolute zero. Due to this icy starting point, it seems that Pluto is far too cold for all life forms known to us. Or is it? Well, not necessarily, but more on that in a moment. First, we should consider why the thermometer on Pluto falls so extremely far below freezing point. This is simply due to the immense distance between the frozen dwarf and the Sun. While the mean distance between Earth and the Sun is around 150 million kilometers, Pluto orbits our central star at a gigantic distance of 6 billion kilometers. As a result, it takes Pluto a whopping 248 years rather than 365 days to complete a full orbit around the Sun. When it comes to the actual composition of the celestial body, Pluto's atmosphere consists of 99% nitrogen, while its surface is dominated by nitrogen ice. The massive core, which corresponds to about 70% of Pluto's diameter, is mainly composed of rock, surrounded by a mantle of water ice. But despite its modest dimensions, the dwarf planet is by no means alone on its journey through space. It is accompanied by at least 5 moons, of which Charon is by far the largest. In fact, this natural satellite, with a diameter of around 1,200 kilometers, is half the size of Pluto itself, which is why some experts believe it makes more sense to consider the celestial bodies not as separate entities but rather as a Pluto-Charon double system. It may be that we are dealing with a double system that was formed by an astronomical kiss. While researchers have long assumed that Pluto and Charon came together as a result of a catastrophic collision, more recent models suggest a so-called kiss-and-capture scenario. This means that the two celestial bodies collided but remained largely intact. Fortunately, the NASA probe New Horizons, which on July 14, 2015, more than 85 years after its initial discovery, became the first spacecraft ever to swing by the remote reaches of Pluto, also remained intact. The 480 kilograms probe took more than 9 years to bridge the enormous distance between Earth and the dwarf planet. Pluto was still officially listed as a planet when New Horizons plunged into the vastness of the cosmos on January 19, 2006. Although the spacecraft has long since left the celestial body and, in just under 20 years, will pass the boundary into interstellar space in the best Voyager manner, the evaluation of the Pluto data is still in full swing. Nevertheless, the information evaluated so far has already brought to light things that left terrestrial researchers open-mouthed. For example, the experts realized that Pluto's face is in fact much more dynamic and varied than previously thought. The landscape is not only dominated by cliffs of nitrogen ice reminiscent of the rugged coasts of Scandinavia, but also by gigantic methane ice blocks, some of which are as tall as skyscrapers. But that's not all. Pluto also has dormant ice volcanoes that dwarf even Mount Everest, as well as canyons that plunge even further than the Grand Canyon. With regard to the 3,500 high mountains on the southern edge of Sputnik Planitia, experts assume that the mountain range consists of water ice because, under the bitterly cold conditions, this is as hard as stone. Nitrogen ice would simply not be stable enough to form such massive structures. Apart from that, we still have no idea how these special Pluto mountains were formed at all. This is for the simple but crucial reason that there is simply no more massive celestial body in the realms of Pluto that could deform the crust to such an extreme degree. When New Horizons arrived at Pluto, it reached a breakneck speed of 52,000 kilometers per hour. The probe was traveling so fast that it only got to see one side of the celestial body up close, specifically the hemisphere that was bathed in the light of the distant sun at the time. The opposite side of the dwarf planet, on the other hand, was literally in the dark and could only be explored by New Horizons in the days before and after its closest approach. Experts initially evaluated the close-up images of the sunlit hemisphere, but Pluto's shadow side has now come into astronomical focus. The corresponding images are not nearly as sharp as those of the other sides. Only landscape formations with a resolution of 2 to 30 kilometers can be recognized here. However, what at first sounds rather rough is in fact 250 times more precise than the insights of the Hubble Space Telescope once provided into the remote ice world. Accordingly, the New Horizons images show Pluto's composition in unprecedented detail, even suggesting the groundbreaking conclusion that the bitterly cold celestial body could ultimately be hospitable to life. Experts have long suspected that the dwarf planet is hiding a soaking secret, a huge underground reservoir of liquid water. As we all know, water in a permanently liquid form is one of the basic requirements for the development of life similar to that on Earth. But how can it be that the water on Pluto remains liquid when average temperatures of -233 degrees Celsius prevail there? A few factors can reduce the melting point of water. Most notably, salts dissolve in water and high pressure. Additionally, friction caused by tidal forces converts some of the kinetic energy into thermal energy, preventing the water from freezing into ice. If the hidden ocean really exists and even has inhabitants, experts agree that it would by no means be a highly developed underwater civilization, but rather simple microorganisms. This is supported by the water traces on the nearby hemisphere, which have left a reddish shimmering discoloration. The discoloration represents an indication of a high concentration of organic molecules, a prerequisite for life. It is conceivable that their origin lies in cosmic radiation or solar wind. Experiments have shown that such complex reddish compounds can arise when molecules such as water, methane, or nitrogen are exposed to radiation bombardment. If ammonia is also involved, the bases that we find in RNA and DNA can even be formed. Particularly exciting is the article published in the journal Astrobiology by a team led by New Horizons researcher Dale Cruikshank. It lists evidence suggesting that the ice on Pluto is not only red but also contains ammonia. However, the authors emphasize that this is far from proof that the dwarf planet harbors extraterrestrial organisms. The results only show that microscopic creatures could survive there. 2 out of 3 conditions for potential life have already been met, indications of liquid water and the presence of organic matter. What is still missing is a suitable energy source to maintain life-friendly conditions. We can look forward to seeing if and when Pluto will reveal this lost secret.